Here's one more separable equation. At first it doesn't look very separable, but we could try to factor. When there's four terms, grouping sometimes works, and so I'm going to try pulling an e to the x out of both of these. And sure enough, you pull an e to the x out of this, you have e to the minus y plus 1. And then there's here, and we have basically 1 times e to the minus y plus 1. So there's this common number, e to the minus y plus 1. I can factor it out, and I have e to the x plus 1 times e to the minus y plus 1. If I separate, I have dy dx over e to the minus y plus 1 is equal to e to the x plus 1. Let's integrate both sides with respect to x now that things are separated. And we get on the left integral dy over e to the minus y plus 1. And on the right, this integral is pretty easy. Antiderivative of e to the x is e to the x, antiderivative of 1 is x. Okay. This one requires a bit of a trick, and the trick we can use is to multiply top and bottom by e to the y. So you have e to the y dy on the top. E to the y times e to the negative y is 1, and e to the y times 1 is e to the y. Now because of that trick, that's all equal to e to the x plus x. Because of that trick, now I can see that I have the derivative of the bottom is e to the y. So I have the derivative of the inside over the inside. That's a natural log. So we have the natural log of the absolute value of 1 plus e to the y is equal to e to the x plus x, plus there's arbitrary constants that come with both antiderivatives. Combine them into a single arbitrary constant over here. Now actually in this case, 1 plus e to the y, since e to the y is greater than 0, 1 plus e to the y is greater than 1. So this is definitely positive. No need for the absolute values in this case. So 1 plus e to the y, e to the x plus c. Now at this point, I would solve for y. However, I have some initial data that I could use here. So my initial data says that when x is 1, y is 3. So since I have the constant almost alone here, now's a good time to find that constant. So this says that the natural log of 1 plus e to the y, but y is 3, so 1 plus e to the 3 is equal to e to the x. If x is 1, that's just e, plus x, that's 1, plus c. So we know that our constant, because of this initial data, the constant has to be the natural log of 1 plus e cubed minus e minus 1. Now I could put that in and finish solving for y. So we know the natural log of 1 plus e to the y, I'm going to take this and put it in for c, is equal to e to the x plus the natural log of 1 plus e cubed minus e minus 1. Okay, now to get rid of the natural log, this says the exponent you put on e to get 1 plus e to the y is this big thing. So I'll go ahead and do that. Write it in exponential form. E to the e to the x plus the natural log of 1 plus e cubed minus e minus 1. Finally, take away 1 from both sides. E to the y would be e to this big expression plus e cubed minus e minus 1, all minus 1, and then to get y alone, take the natural log of both sides. So y is the natural log of e to the x plus the natural log of 1 plus e cubed minus e minus 1. And we've solved our initial value problem.